This is Foundations of Math and Pre-Calculus 10, Chapter 6.1. We're going to be looking at graphs of relations. Although graphs generally do not provide a great detail of precision, a table of value does. However, graphs very quickly convey how a quantity changes. If it's level, that means there's no change. If it gradually goes up, we call this a slow increase. It doesn't matter what the vertical quantity is, and it doesn't matter what the horizontal quantity is. This is considered a slow increase. Here, we have a fast increase. Here, we're going down, so this is a slow decrease. And lastly, we're going down very steep. This is a fast decrease. Okay, let's look at this problem. And we're looking at speed over time. And we're going to describe this as the motion of a car. So, in section 1, car is accelerating from stop. And that's because we start at 0. So 0 speed means it's stopped, and we're increasing. Here, the car is not changing speed, so car is cruising at, say, the speed limit. And at step 3, it's doing two things. It's slowing down and then speeding up. So what would make a car do that? It doesn't come to a stop, it's just slowing down and then speeding up. Well, it could have been letting in a merging car. Okay, 4, it's cruising at speed again, so same as 2. And then 5, again, it just slows down and speeds up again, so we'll say that's the same as 3. It's letting a car merge in. 6, that's the same as 2. Okay, it's just cruising at the speed limit. And 7, it is slowing down very, very quickly. So it could have been a sudden stop from, say, a kid running across the street. Okay, and we look at 8. 8, it's accelerating slower than 1. So it slowly accelerates. And it could be because of the scare from stopping for the kid that was running across the street. Okay, 9. And because of that scare, he's driving slower than the speed limit. Cruising below speed limit. There could be other reasons, but these are just plausible reasons. Okay, 10. So now he feels that he's okay to go faster again, so he's accelerating. And he's going faster than the speed limit. And we could say that he's just trying to make up time that he lost for stopping for the kid. Again, this is cruising above limit. Miswriting limit there. Okay, and then 12, he's stopping slower. Okay, so it's not a sudden stop here. He's just stopping probably normally. So stops at destination. Okay, so that gives you a very general picture. You can see exactly what's going on. You don't see exact values, but you see trends. Okay, and just some terminology. The vertical axis is called your dependent variable. Your horizontal axis is called your independent variable. We can't change time. Time just constantly goes across here, but we can change our speed. Our speed depends on the time. So if our time was here, our speed was here. It was cruising. If our time was here, he was doing a sudden stop. So the speed depends on the time. And for a lot of these real situations, we frequently see the horizontal axis is time. Time is rarely on the vertical axis. Okay, so let's look at some real life examples. So here's the world population, starting from 1 AD all the way to 2050 AD, and those are all estimates. Okay, we haven't hit those dates yet. But we can see that the human population grew very, very slowly. We see that starting at the 1800s, population starts increasing very rapidly. And you could take guesses as to why. And, some of those reasons are farming, medicine. Farming makes food more readily available. Medicine lets people live longer. Lifespan's been increasing, so the population increases. Other things, technology. It makes our houses safer, and because of that, we are more comfortable and have less accidents. And believe it or not, even with the violence in the world, it's still safer than before, and that's why population has increased. Here's a look at the watershed for Metro Vancouver. Now, you can't tell exactly what's going on, but you can have a feel. So this is always between May and November. So again, we have the horizontal axis is time. And let's look at the current year, 2016. We can't tell what's happening exactly, but the water levels are going down slowly. And that could be because people are using less water, or it's raining at the same time as people are using water. So rain adds to the water level, but people are using more than it's raining, so it's still decreasing. But we can't tell for sure because we don't have the data for rain. And it's better than the previous year, but if we look at the 2014, there was very little water drainage. So that must have been because it was raining at that time, as well as when people were using the water. Here, you can definitely tell there was a lot of rain because it goes up. We can't have negative water consumption, so rain must be the only contributing factor to make it go up. And here, we can look at this. It must have rained a lot over this period to make it go up that high. And you can see pretty much every year around this time, we get a certain amount of rain. And over the summer months, you can see a lot of water usage or lack of rain. So we can tell a certain amount of information from the graph, but we can't know exactly everything because we don't have the rain data. And that completes this lesson.